All right. So yeah, let's go to Schoology, and we're gonna check out the Chapter 2 test. That was the most recent, and it was the one that was harder than Chapter 1. It just had more calculations to do. Let's see. So yeah, if you click on it, is it popping up like this? Like you should have some checks, some X's. Everyone's order of questions is not going to be the same. So you're just going to have to scroll around until you get the question that I'm also looking at. All right. Y'all finding it?
Ooh,
Yeah.
I just saw 0 out of 5.
Oop. Okay. There. Feeling okay? Almost.
Found it.
Got it. Does it have the checks and X's?
No, it just said 0 out of 5 or 5 out of 5.
Oh, that's
It was a
kind of annoying.
5-point question. I thought these were worth like 2.
No, yeah, they're like 50-50. So the free response is 50 points. Multiple choice 50. All right, so yeah. Well, at least it says 0 out of 5, so that's good. Okay, so let's go to this problem. This could be anywhere on your test. It could be your first question. It could be your 14th question. So it's scrambled. Huh?
The one where, let's see, for me it was my first one. It was like the question, referring to the question above. Oh, that makes sense.
Yeah, but I think on that one I had it. We'll get there. Yeah, we'll talk about it. Okay, let's look at this. So on this one, I think this was one where I'm just gonna highlight a few where there were some mistakes. So this one, I remember some people had made a mistake on this one. So this says, for the density curve shown in this question, what statement is true? So this is a density curve. It starts at 0, goes to 1. That means that, so this could be representing anything, like any sort of distribution here. And under the curve here, we've got this distribution. So it looks like the answer choices are talking about the mean and the median. Which one's greater, less than the median, whatever. So this data is symmetric. This is a symmetric data, and so on symmetric, the mean and median are equal. So it should have been C, the mean and median are equal. Just knowing symmetric, those are equal. So yeah, that one's pretty straightforward. And if y'all have a question as we do it, let's see. Bless you. I think some people did, so I'll just go through it. Probably just end up having to go through all these because, different people miss different problems.
Ew, I hate my face in these pictures like flipped around behind.
All right, so I had a normal distribution with a mean of 9, standard deviation 2.5, and we wanted more than 10. On this one, I think, if I'm trying to remember, let's see. Oh yeah, so the correct one is B here. And I think if you missed it, you put C, most likely. Because what happens is you do the z-score, you do 10 minus 9 divided by 2.5, and it's something, I could probably do it, probably should do it. You look that up on the z-table, and on the table, it tells you the number probably close, it's like 0.6550, something like that. So then you're like, oh yeah, 6550. Oh look, there it is right there, 655. That's the right answer. No, so this is talking about greater than. So when you're looking at it, I know we don't have this, the multiple choice is not printed out, but like just scratching on your paper that I give you for free response, like drawing yourself pictures, making sure that you're not making mistakes. Because when I draw a picture, this is definitely not 60% of the curve. It's like this upper little tail. So then when you try and circle 65%, something in your brain might click in and say like, oops, that's not the right answer. Let me think about this. So you should have done 1 minus it for 34%. All right, what was this one? Overall, the free responses I mean, they were mixed, but I felt the few responses were actually pretty good overall. Mostly the multiple choice were the ones that got wrong. But like on this one, you do a z-score, and she only has $15,000 to spend. The mean is at 14,000. So if she only has 15,000 to spend, that would be like 15,000, and this is all the room in my budget, less than. So you do the z-score, look it up on the table, and get your answer. The 30th percentile. So a percentile means that you are above 30% of the people. So 30% of the people are less than you, because you're above them. 30% are less than you. So you're right here, and 30% of the distribution is less than you, because you are above them. That's what that means. So that's what you're solving for on percentile. You go look up in the table the closest value to 0.300, which looks like they got this one right, so let's just talk about this one. Oop, there you go. So, negative 0.52. Okay. Yeah, I think I'll just hit on the multiple choice, or any other questions you might have. Okay, this one, I'm remembering some people getting this one wrong too. Jadely, I think this was the one you were talking about, because it says described in question 3. This was, I like cut it up above. So like this, or it wasn't this one?
It was,
okay, well I guess we'll get to it. Okay, well maybe we'll get to it. So, so we have, suppose a 16-ounce bag of chocolate chips have a mean of 16.1 and a standard deviation of 0.1 ounce. So then, from this question, approximately what percent will be less than 16? So I have 16.1, and then I've got 16, and I want to know the percent less than. And it says that this is, one standard deviation is 0.1. So we went -1 standard deviations. And so you could have done the z-score of this and done the table, or you could use the 68%, and then there's 16 and 16 on the edges, because it's symmetric. So it would be 16 there. But if you did the z table of this too, you should have gotten 16. So you didn't necessarily even have to remember the 68, 95, 99.7. So yeah. Again, if I hit one and you're like, I really don't know what you're talking about there. Okay, this one.
That's the one that in the previous question.
Okay. Yeah. But we actually didn't really need the information above it there. But yeah, this one was tough. This one was probably the most missed one of all of them. So yeah, in the previous question, the finish time was this. The main thing is that it gave you the mean, it gave you the standard deviation, and then it said the distribution was skewed to the right. So basically it's saying I did have a skewed to the right distribution, and I had somewhere was a mean of 2.164 there. So here's the difference. It says, what are the mean and standard deviation and the shape of a z-score? So like a standardized table, like if I make it a z distribution. And so I probably know why this one was most missed, because I think I did this lesson with you virtually, and so maybe that one didn't, this didn't come through as clearly in like my online lesson or whatever. And it was on the first homework, which that whole first section maybe got missed. But if I have a z-score, like the z table of digits looks like our z-score, the whole point of converting my things to z-score is that they make a normal distribution. So if I take my data and I convert it to a z-score, the z-score then converts into this normal distribution where it centers around a mean of 0, and on the z-table, one standard deviation is like, I go like this, 1, 2, 3, so it would be a mean of 0, a standard deviation of 1, and the shape is normal. So that one was, yeah, I mean, I know why it was missed, just because it didn't come through maybe as easily in like a YouTube video, especially for y'all that haven't really had to watch those because you've just had in-person lessons. But, and this is just a kind of a tough one, but when I convert my values to z-scores, this is like kind of a big deal of the z-score, is that no matter the distribution, when I convert it, it becomes normal. So it's really helpful because then I can do these whole distribution things. Yeah. So, yeah, like common answer was like this one because that's the same thing, or this one, and so that one was kind of a tougher one. Yeah, so when you convert your values to z-scores, those become normal. Okay. Let's see. Oh, okay. I do want to talk about, this one seemed to be confusing for some, this B here. So in this problem, we had the Boston Celtics had a normal distribution with a mean of 99 and a standard deviation of 10. So this is my picture for the whole problem. It says the mean number of points for the Los Angeles Lakers was 101.7. In what proportions of their games did the Celtics, so in what proportions of the Celtics games did they score more than the Lakers? So in what proportion of this little world here, with the 99.2 as our mean, did we score greater than 101.7? So I look at this at 101.7, and I'm looking for the proportion that was greater than 101.7. So it asked it in maybe a way that you could set up a picture wrong, but it was saying like, of all the Celtics games, here's the Lakers, and then so how many of these Celtics games did they score more than the Lakers average? And here's their average at 101. So you do the z-score, and you look it up on the z-table, and then you have to do 1 minus that value because it's greater than. So a lot of steps. Okay, let's see. Oh yeah, this was one. This was definitely one that got missed. Alright, this one, for the density curve shown, what statement is true? So what does this picture look like? The most common mistake, if you missed this, was that you said the density curve was normal. But on this, so this picture, like the picture is kind of like arced, like almost like a free throw or like a basketball shot or something like that. But a normal distribution kind of comes up here, and it kind of has like a bend on it, and it peaks like that. So this one's, would that be like concave versus convex, you could almost say? Like this one's caved in, a normal distribution, and this one's like popped out almost. I don't know. But a normal distribution has a little bit different of a picture than those. So the one about this one, which if you did this problem, and when you got to here, you should have been confused then between those two, because this is definitely symmetric. So like, if I look at this, and this is definitely symmetric, is it normal? Well, I don't know. I'm thinking if you chose normal, you might have just like saw normal and circled it and moved on. So, but like symmetric is definitely the better option there. It's definitely symmetric. All right. And let's see. This one. Anyone want me to go through? Want me to go through this one? Anyone feeling like they didn't know that one? Okay. I can do it. And I can always talk about these later. Okay. This random person that I chose here got this one wrong, but I felt like for the most part people got this one right. But I can talk about this, I guess. So the area under the normal curve, standard normal curve, so that just standardized is a z, was just another way to say that this is a z, which it told you that there anyway. So it's basically setting up a picture. So maybe that was the tough part of these multiple choices, is that you didn't have scratch paper on it to like, just use or you can have your own notebook scratch paper that's empty too. But I've got a z-score of negative 0.3 to positive 1.6, and I'm wanting to know greater than but less than that. What's the area between those two? So what you do is, so I can look it up, just get our right answer here. Oops. So you look up negative 0.3, 0, 0.3821. So less than that is 0.3821. Less than 1.6, 0.9452, which was 9452, which is none of the above right now. But we're trying to find that in between value. So this goes all the way to infinity, 38 goes all the way to infinity. So there is this little gap here where if I take away this 38% from the 94, so 9452 minus 38 ends up being that C value, that 56%. Alright, seeing some errors, seeing some gaps. This one is also, it's the same picture, so I'll just keep going for it. So we actually used this one earlier. I had a mean of 16.1, standard deviation 0.1, and I have a value at 16. And then this time they're asking, what is that part? So you could do it just like I just did. Find the z-score for this one and look it up in the table. Find the z-score for this one and look it up in the table, and you could get that number. But the key here was that we were a perfect -1 standard deviations away. So you have like a middle 68%, and so without even doing the z-score, that is 34%. And then there's your answer. But you should get 34% if you just converted them to z-scores too. So either way. That one went okay. This one, these last two. Yes. That one was okay. Okay, here we go. So, was this one? Maybe this one. Oh yeah, this one got missed. So, on this one, this is a cumulative frequency graph. So like, just looking at it, it looks like we had a ton of values here at the beginning, and then we had some more, and then we didn't really have a lot to add on to, because cumulative just means I add as we go. And so this little part over here is basically your percentile of where you're at. So by the time we reached the end here, we were at 100%, and I started at 0%. So what proportion finished the race in more than 2.15 hours? So you go to 2.15, and it's right here. And if I was to estimate that number on the cumulative amount that we're at, it looks like this is at 55%. So basically that means that was 55% of our data up till then. And so then you came over here and most people clicked 55%. But it said more than, so it's talking about who then was after that. How many people then trailed off from there? So that would have to be 45%. So then there's your answer, 45%. So the most commonly missed problem there was just, I don't know, seeing that it was 55 and clicking 55, or I wasn't quite sure on that one. I didn't think that one would be too bad, but it ended up being kind of a commonly missed one. So, I mean, I can definitely see how it can trick you, but just reading that more than, less than, faster, whichever one. Alright, and then another one that I can see how it got tricky, but I didn't expect it to be a tricky one at all. But I can definitely see where maybe it didn't go as well. So I had 50 randomly selected colleges, and this is the professor's salary. So what bin contains the 80 percentile? So what person, where's our value that I had 80% less than or equal to? So if I had 50 people and I'm looking at the 80% person that's less than, there's many different ways to do this. This is the way I did it. I thought about it was I did 50 times 80%, and I'm looking for the person who's ranked number 40. Is the way I did it. And so you had to use this part over here. You had to get the counts. So this was at 3, 6, 18, 9, 9, 4, and 1. So when you do that, I'm looking for the range of that 40 person, that person who's in the 40s. So 3, 9, 27, so all of those are out. 27 plus 9 is 36, so that bin is out. And somewhere residing in this little area right here resided that 40th person. So that was the range of 63 to 68 there. So just kind of using the counts of the bars to go from there. I mean, it could have been a lot of different ways that y'all could have missed that, but just realizing the right way. So just realizing what the frequencies were, and that 40th person was somewhere in this little box. So. And the last one more I didn't do. Okay. Yeah, talked about this. Might as well finish it up. So the proportion of scores of a standard normal, so that was just a Z table, greater than 1.25. And so a Z score centers around 0. We're talking greater than 1.25. So you look it up on the table, 1.8944. And so we're talking about greater than 8944, so it was this like 10.5% there. So I really just want, we can do whatever with these Wednesdays, AP problems, talk about tests. So is it helpful to go through, is it nice to see what you're missing and understand? Do you want to see some AP response, seeing some okay things? All right. So we will do that with time. 9:20. Okay. So we still got 25 minutes. Yeah, it's just, there's always, with the math test, it's just little mistakes, like you could know what you're doing and just, it could be any little mistake that you did. And could be rounding, you could have done greater than or less than mistake, or read the table wrong, could be many things. So just kind of taking your time, looking at the problems fully. Let's see. Okay, I'm gonna look at chapter 1, and you can check that out too if you want. I might not look at, off the top of my head, I'm gonna try and remember some commonly missed. So maybe you can just kind of see what I'm talking about up here, instead of trying to find it on yours. But I remember for sure that this one had some misses on it, on the chapter 1 test. The following bar graph gives the percent of satisfied with their trucks: Ford, Chevy, and Toyota. And the problem with it was that over here, these numbers are 95, 96, and 97. So the true difference between Ford and Chevy was 2.5%. It was nothing. But they made their graph to where it looked like there was a huge difference between Ford and Chevy, when in actuality, it just didn't start at 0. So I think it was C. There's only a small difference between the satisfaction of the owners. So they just had the bar. It didn't start at 0. The graph was a bad graph. Standard deviation is how far away we are. So C has the smallest standard deviation, B has the biggest because it's most spread out. So standard deviation is how far away you are from the mean. That one was fine. That one went okay. Can't remember which ones were trouble. Overall, we did better on this one. So. Yeah, I honestly can't remember. Oh yeah, I doubled up a question. I forgot about that. That was a mistake. Oh yeah, that one was maybe one that got it wrong. So the interpretation of what a standard deviation is. So standard deviation on the surface is just the average distance you are from the mean. So on average, where are your values distance from the mean? So not every single value is within there, it's just on average how far is that value away. So on this it said all the infants are 1 standard deviation away. Or half the infants are 1 standard deviation away. But the true one was the distance between the weight of the infants born in April and the mean weight was on average about 10.2. So the average distance of the weights from the mean was that standard deviation. So that's what, and it's different seeing it written out in a sentence like that, but it's just the average distance you are. I'm trying to look at E, the mean weight. The problem with E is that it's like the mean weight of the next months is likely to be within that. So that's not what standard deviation means. It means like for the data that we had, this was the standard deviation. I don't know what it's going to be in the months to come. Things could change. But for what we had, it was that distance. All right, I think that's good. Okay, so with the rest of our time, 20 minutes, you can work on the homework. You can ask me a question that I didn't go over, or ask me to clarify one of these test questions, chapter 1 or chapter 2. You can work on the progress checks. You can work on another class. Work on another class, no way. So whatever you need. All right. Sweet. I need